Okay, so in this video we are going to move on from singly linked lists and consider a variant called circular linked lists. So very simply, a circular linked list is one that looks like the following image here. So same things apply from singly linked lists, namely we have a head node. Each of these boxes is referred to as a node. Every node has a data and next pointer. So the data element of this head node here is A, the next pointer points to B, the next pointer here points to C, and the next one here points to D. Now, usually in a singly linked list, as we saw before, this last node would point to null, but the name circular, indicates that this is a circular list, namely that the last node in this list doesn't point to null, but points back to the head node of the list. So it's circular in that way. So a circular linked list we'll see can be used for solving certain problems, but before we go on to those problems, we're actually going to code up in Python an implementation of a circular linked list. Let's go ahead and see how we can implement this circular linked list in Python. So I've already started to set up some of the scaffolding for a circular linked list. A lot of this should look familiar if you've watch the singly linked list video series. Namely, we have a node class. So just like before, the node class is absolutely identical. There's an element in the constructor here for data, which we can set in the constructor, and there's also an element for next, which is the next pointer of the node. So it's exactly the same. We'll define a class which is called circular linked list instead of singly linked list. And the constructor in this class is identical to the singly linked list, namely that we initialize the head initially equal to none. And the functions for prepending, that is adding an element to the start of the list, appending, adding an element to the end of the list, and printing the list are all going to be a little bit different. So we're actually going to code them up from scratch and try to understand the structure of the circular linked list in doing so. So the first thing that we're actually going to do is we're going to append some elements to the list. So appending, again, is adding on to the end of the list. So remember, in the figure here, we have this list here. We want to add on to the end of the list. Now before, if we had, let's say we have these two nodes already in our list, what we would do is we would just traverse from this node to this node all the way through and check, is the next node none? If it was, then we would replace none with the new node, and then we would have the new node point to none. Where instead in this case, we're going to check where the next node in this case points to the head. So this is the last node. The next pointer of this node points to the head. And so we know this is the last one. So we're going to say, okay, the next pointer of the current last node should instead point to the new node. And then that new node should be pointing to the head of the list. So it's a little bit different, but let's go ahead and code that up and see if we can figure how to tell Python how to actually append a node onto a circular list. So what we have to first do, let me actually go back to the image. There's two cases really. So one case is that we don't have any elements in the list. So that is, we don't have any head element in the list at all. So in that case, that's very easy. All we do is we just set the head of the list equal to the new node that we've created, and then we set the head dot next, essentially this thing here, to point to itself. So again, it's a circular list. If we only have one element in that list, the next pointer of that one node is going to point to itself. So let's go ahead and code that up. So that's one case, if not self.head. So if there is no node in the list, let's go ahead and put one in there. So let's set the head of the list equal to node of data that we get passed in. So now we have a node and it's set to the head of the list, and since it's a circular list, we need to have the next pointer of head point to itself. So we'll say self.head.next equal to self.head. So what's the other case? The other case, let's go back to the slides. The other case is, let's say we have two nodes, and again, if we just had A and B, the dot next of B would point in a singly linked list to null. But in a circular linked list, it points to the head of the node. So even let's take this full list. So this is the last node of the list. It points to the head of the list. If we wanted to insert a node, let's say E, into this list, we would have to update the next pointer of the last node to point to E, and then E should point to the head of the list. So let's go ahead and figure out how to do that in Python. So first of all, let's go ahead and create the new node based on the data that we got in from the function. So we'll say new node is equal to node of data. And then what we're going to do is we're going to define essentially a pointer to the head of the list, and we're going to move that pointer along until we get to the last node. And the last node, again, we can find out whether or not we're on the last node by checking the next pointer, and the next pointer of the last node should be pointing to the head. And that's how we'll know that we've reached the last node. So let's go ahead and say current is equal to self.head, and then while current.next is not equal to self.head. So basically, what is that saying? So we start off here, current is here, and we move on while current.next is not equal to head. So current.next is set to B, okay, keep going. This is set to C, okay, keep going. This .next is equal to D, and then we check this one. This D, this node that holds D.next is actually the head. So we know that we're at the end of the list. So we need to change this arrow around here because we're adding a new node to the end of the list. So in that case, what we're going to say is we're going to continually move on down the list. So current is equal to current.next. At that point, we'll have the last node. So we'll say current.next is equal to the new node. So at this point, what we've done, to go back to the slides, let's say we had E here. So this .next won't point to this head anymore, but it'll point to the new node E. And then what we want to do is we want to say the new node, so new node.next should point to the head of the list. So where the previous last node, D in this case, points to the head of the list, we'll have E over here, and the dot next to this thing will point to E. And then we need to say, okay, now the dot next of E should point to the head. So the new node.next should point to the head. And that will pretty much do that for appending. So in order to verify that the append function works, I've actually gone ahead and created a circular linked list object here, and I've appended and prepended some objects onto the list and then printed the list. So we still have yet to actually fill in the print list function and the prepend function. So before we actually run the code, let's go ahead and fill in those two remaining functions. So let's do the print list function next. So let me get rid of this pass. So what we're going to do is we're going to do a similar kind of idea to what we had for the print list function in the singly linked list. Namely, we'll set, let's say, a current node equal to the head of the list, and then we'll say while the current node is not null, well, essentially while the current node is not the head of the list, what we'll do is we'll print out current.data, and then we'll say current is equal to current.next. So we're continually moving on in the list. So right now I'm saying while this is not null, I'm going to continue to print this out. So if this just was as it is, it would continually print out. We would have something that looks like an infinite loop because we don't have anything that points to null. This is never not none. It's a circular linked list. So this is always going to go back around in on itself. So we're going to continually print out current.data continually over and over and over again. So what we're going to do is we're going to have a breaking condition. So we're going to say if current is equal to the head, what we'll do in this case is we'll break. So we'll break out of the loop in the case where current is equal to the head. So that will only print out the data from the start of the list all the way to the end of it. And then once we get back to the start of the list again, we'll break. So now the last function that we need to fill in is the prepend function, which again is adding on to the front of the list. So this prepend function will also look somewhat similar to what we had in the singly linked list function as well, with a few key differences. So the first thing that we want to do, of course, is we want to define a new node. So we'll say new node is equal to node of data. And then what we're going to do is we're going to say current is equal to self.head, and then new node.next is equal to self.head. So what is actually going on here? So first of all, we're creating a new node with the data that we've gotten fed into the function. Then we're setting this current pointer equal to the head of the list. And then we're going to say, okay, the new node.next is equal to self.head. So if we had, let's say, a new node that we wanted to append onto this list, to prepend onto this list, let's say we had one, let's call it 0. We have a node 0. We want to prepend it. So this new node that we start off over here with, the dot next of that thing should point to the head of the list. So it should point over there. So that's what we're doing in this line over here. We're saying the new node.next should point to the head. Now there's two cases, just like there were in append. Basically, we either have no other elements in the list, that is, it's an empty list and this is the first node, or there's other elements in the list, and we'll deal with that, each of these cases specifically. So let's deal first with the case where this is a new element in the list and we don't have any other nodes. So essentially, if not self.head, so if there's no other elements in the list, we'll say new node.next is equal to new node. So again, this is kind of putting in the link in on itself. So if we just had one node and we added A, we prepended A onto this list, well, this wouldn't point to, just imagine all of these other nodes were gone. This wouldn't point to B, this would point to A again because this is a circular linked list. So that's easy enough. That's very similar to this case here with append, where we don't have head set, so we need to make sure that it points back to itself because it's a circular linked list. Okay, so now let's think about the else condition there. So the else condition covers the case when there's at least one node in the list. So what we're going to do in this case is we're going to say while current.next is not equal to the head of the list, we're going to just move that current pointer along in the list. So current is equal to current.next. And then at the end of that loop, what we're going to do is we're going to say current.next is equal to the new node. So we're prepending that onto the list. We're moving all the way to the end. We're going to keep going through this list here, and then we're on this node. This node.next should be equal to the new node, and the new node will be pointing, will be the new head of the list, because again, this last node should be pointing to the head of the list. Right now it's pointing to A, we have a new node instead, and so we want this to point to that new node, which also means that instead of this node being the head of the list, we need to make sure that we update that appropriately. Namely, we say self.head is updated to be the new node. Because again, that's being prepended, putting onto the front of this list. So let's go ahead and verify that everything worked there. So again, what I did here is I defined this circular linked list object. I appended C and D. So we should see, at least in that case with just C and D, we would see CD. And then I also prepended B. So onto the front of that CD, I put a B, and onto the front of that BCD, I put an A. So with any luck, when we print out this list here, we should see A, B, C, D being printed out. Let's go ahead and write that and give it a run. So we see this list, which it seems like the functions are working as expected, A, B, C, D. So we have our circular linked list. So that pretty much does it for this video. In subsequent videos on the series, we will cover other things we can do, other operations we can do with circular linked lists, and other problems that you might encounter in a data structures course or in a technical interview. So thanks again for watching as always, and for all the support and subscriptions. Until next time, I'll see you. Thanks again. Bye-bye.